In today's lesson, we are going to be looking further at Venn diagrams. So we've looked at Venn diagrams previously to try to visualize some probability scenarios looking at different events and whether they overlap or how they overlap. So we're just going to be looking further at that just to get more comfortable with coming up with or creating them. So in the first example, there are 78 students enrolled in music courses at Crosley. There are 42 students in the band, 26 in the vocal ensemble, and then there are 18 students that are in band and vocal. So we want to represent this information in a Venn diagram and then figure out how many students are in just band or vocal and not both. So we have our scenario, we have our sample space here. It is overlapping because we do have a scenario where they are in both. So what we want to do, or things we want to represent, one, we want to represent how many are there in total in our sample space. So in total, there are 78 students in our sample space. We get that from the question. Now we need to start to fill in information into our specific events or outcomes. So one is band and one is vocal. Use two different colors to represent them here. And then we do have an overlap. So when you're doing a scenario like this, you want to start with the overlap first. Start where the outcomes or the events overlap. So in this case, we have 18 students that are in both band and vocal. So that overlap is going to be 18. What we want to do then is now use that overlap to help us figure out how much is just remaining in each one. Right? Because when we look at the band represents this entire circle. So everything in this circle needs to add up to 42. So 42 students in total that are in band, 18 of them are part of the overlap. So the remainder is going to be 42 minus 18, which is 24. So there are 24 students that are in just band. For vocal, you're going to be doing the same thing. All the vocal students are encompassed or are included in this circle or this outcome. We already have 18 from the overlap. There are 26 in total. 26 minus the 18 equals 8. So there are 8 students that are just in vocal. Combined with the 18 in total, there's 26. There's your 26 vocal students. Now, if we were to go through and look at all those individuals, so 24 plus 18 plus 8, we find, okay, there's 50. There's 50 students there. However, I actually have more than 50 students. There are 78 that are enrolled in music courses. So in this scenario then, I'm missing a couple people. Where do I represent that missing number? Well, if there's 50 that are in band and vocal or both, and there's 78 in total in the music courses, then that means that there are 28 students that have not signed up for either band or vocal. So they're existing outside of those two scenarios. So that is now our sample space. We now have enough information to go through and figure out how many students are just in band or vocal. In this case, just one or the other. So we have 24 students plus the 8 students in vocal. Then we have 32 students in total that are just band or vocal, not both. In the second scenario, 18 students on council, 12 of them helped with the first dance, 14 with the second, and 3 didn't help out at all. So then we want to figure out how many students helped out with both dances. So we can start off looking at our sample space. There are 18 students. Again, we get that from our question. We're going to look at the first dance and the second dance as our two outcomes or two events. So now we need to figure out, okay, where are we? Well, we know right now there are 3 that didn't do anything. We don't have enough information to fill out the rest of the diagram right now, because we know how much helped out in total in the first one. Right? We know there's 12 in total here. We know there are 14 in total in this one. Wrong color. We know there are 14 here in total, but we don't know how many are in the overlap. But we can go through and calculate that, because in total, it has to add up to 18. So 18 plus the 12 that helped, plus the 14 that helped in the second dance, plus the 3 that didn't help at all, minus our overlap. Right, so our overlap is going to be represented just by a variable by x. So essentially what we've done is we've gone through and added it all up, counting group twice. So we have to figure out, okay, well, what do I have to subtract? Right, what do I have to remove to account for that overlap? So 18 would then equal 29 minus x. Solving equations, so we can move the x over, bring the 18 over. Essentially, this becomes 18 equals 29 minus 18. X equals then 11. So that means that there are 11 students that helped out with both dances. So we've answered our question. 11 have helped out with both, but let's fill out the rest of the table, or the rest of the diagram. So in this case, we know that there are 14 students in total for, not 14, 12 in total for the first dance, minus the 11 that in the overlap. So that equals 1. So there's 1 student that just helped in the first dance. For the second dance, 14 minus 11, the overlap is 3. So only 3 students just did the second dance. 11 in the overlap. And we add all of those values up. 1 plus 11 plus 3 plus 3 gives us 18. So it's 18 in total. Another scenario. So at St. Mary's High School, there are 12 players on the school basketball team and 11 players on the volleyball team. How many players could show up at a party for both teams if exactly 5 students play on both teams? So in this case, we don't know how many students there are in total. So we don't know how many individuals there are in this sample space. We're assuming that there's no one else in this scenario that doesn't play on either team. So you do have to make that one assumption here. And what we're going to do is we're going to start with the middle. So we have our basketball first. It's going to be this circle. We have our volleyball represented in this circle. And we know how much is in the middle. We know that there are 5 students on both teams. So we know there's going to be 5 in the middle. So again, here we're going to use our reasoning, kind of removing the overlap. So if 12 players play on the basketball team, minus the 5 that play on both, there are 7 in total that just play basketball. And we do the same thing for volleyball. 8 players on the volleyball team, minus 5 in total that play on both. That leaves us with 3 that just play on the volleyball team. Now we do want to figure out how many students in total would show up. So 7 plus 5 plus 3 equals 15 total. So there are 15 total students that would show up to a party, or that could show up to a party. Next scenario. So student council did a survey asking students who went to the first 2 dances. They know that the students to whom they gave the survey either went to the first dance or the second dance or both, which means that there is no one that filled out the survey who didn't go to either. However, the last question was accidentally cut off the survey. Of 100 students, they know that 48 went to the first dance and 23 went to both. So we need to figure out how many students went to the second dance and how many students only went to the second dance. So there's two parts to this. So let's look at our diagram. We know that there are 100 students. From that scenario, we know that there's 100. We know that there are none that didn't go to neither. So everyone either went to the first dance or the second dance, or both. No one went to neither. So we need to figure out how many students went to the second dance, and only the second dance. So two parts. So where can we start? Well, we know that 48 students went to both, and 48 went to the first dance. So in total, there are 48 that went to the first dance. We know that 23 went to both, so overlap was 23. So if I do 48 minus 23, that gives me 25. So 25 students only went to the first dance. And to figure out the second part, for the second dance, if 23 went to both, 25 went to just the first, then that means that the remainder went to just the second dance. So I can actually find part B first, which is only the second dance, because I know that out of 100 students, take away the 25 that just went to the first dance, minus the 23 that went to both. That gives me 52 students who went to just the second dance. Only 52 students went to the second dance. I can now answer A, which was how many went to the second dance in total. So 23 plus 52 equals 75. So 75 students went to the second dance, and 52 of those 75 only went to the second dance. The last example, so this one is going to be a little bit more difficult, but at a DSBN high school, there are 100 grade 12 students. Of those, some are taking a grade 12 math course this year. The course distribution is as follows. Advanced Function has 52, Calculus and Vectors has 38, Data Management has 41. Students that are taking Calculus and Vectors and Data is 27. Or Calculus and Vectors and Data, there's 17. Calculus and Vectors and Functions is 22. Data and Functions is 15. And there are only 8 students that are taking all 3 courses. So we want to draw a Venn diagram for this situation. And we want to figure out, because we're in the data class, we want to figure out how many students are only in or are only taking data. So here is going to be a little different because we're looking at 3 different events: advanced functions, calculus and vectors, and data. So again, we can label it how we want, or label each circle how we want. So let's say functions is at the top, data is on the bottom, and then calculus and vectors is to the right. Again, it doesn't really matter which way you label it. Now, it might seem confusing on where to start, but the easiest place to start is always to start in the very middle. Start where there's overlap of all 3 courses or all 3 events, because this way we know we don't have to subtract anything. If we look at the very middle, we're looking at all 3 courses. So there are 8 students in the middle. There's no other overlap. We don't have to subtract anything from it. Now we're going to start looking at some scenarios where we overlap. Now, it's going to be the same idea. So if I look at the next one, data and functions. So data and functions represents this part of the graph. So in that part, I need to have 15. 15 students should be in this portion. in this case, 15 minus 8 equals 7. So that means there are 7 students that are just taking data and functions, not all 3. And we're going to go through that same process. We're going to look at calculus and vectors and functions. So we're going to look at this component now. This component. So we know that 8 are already taking all 3. And there are 22 that are just calculus and vectors and functions. So 22 minus 8 gives me 14. So there are 14 students then that are calculus and vectors and functions only. So only in this little overlap between those two courses. And then, again, move on to the next one. Calculus and vectors and data. So here, color. So here, now we're looking at this section, this overlap here that we've done in kind of this baby blue. So in that overall section, there are 17 students minus the 8 that are all 3, and we're left then with 9. So we're left with 9 students that are just taking those two courses, calculus and data. Now that we've looked at those individual overlaps, now we're going to look at the overall circle. So for data, this overall circle here, in total, there are 41 students. So 41 students minus the 7 that are taking functions as well, minus the 8 that are taking all 3, minus the 9 that are taking calculus as well, and this leaves us with 17. So there are 17 students that are just taking data. So we've answered part B, or we figured out how many are just taking data. But we still want to fill out the rest of the Venn diagram in case we need to know how many students are just taking calculus and how many are just taking functions. The process is the exact same. We continue to go through that. So for calculus and vectors, is looking at this overall circle. So in that overall circle, there are 38 students, minus the 14 that are taking functions as well, minus the 8 that are taking all 3, minus the 9 that are that are also taking data, leaves us with 7. So there are 7 students that are just taking calculus and vectors. Finally, the last one, looking at functions overall, looking at this overall circle. So there's 52 students that are enrolled in advanced functions, minus the 14 that are also taking calculus, minus the 8 that are taking all 3, minus the 7 that are also taking data, and we end up with 23 students that are only taking functions. Now you might say, well, I've gone through, I've done them all, I'm finished. However, let's take a look at all our numbers. If we take a look at all our numbers, 23 plus 14 plus 7 plus 8 plus 7 plus 9 plus 17, what do we get? 23 plus 14 plus 7 plus 8 plus 7 plus 9 plus 17 gives us 85. However, the scenario said that we had 100 students. So what that means is that there are still then some students that didn't take any math courses, so they exist outside of this scenario. So there are 15 students because 100 minus 85 equals 15. So there are 15 students that exist outside of those 3 events. So that's how you can kind of use Venn diagrams, or take a scenario and put it into a Venn diagram to visualize where the different individuals or different trials, or different items, how they fit into the sample space. So it allows us to kind of visualize the problem a little bit better. If we wanted to then extend this into some probability questions, we could, because essentially what we're looking at is non-mutually exclusive events, right? Which it can be a little bit difficult to think about, especially when you have to account for overlap. So the nice thing about creating a Venn diagram is that you don't have to worry about that overlap anymore. You can just go to a specific section depending on the question and just take that specific value. So again, make sure you are practicing. Make sure you you have a good understanding of how to basically take the scenario and visualize it or create a visual for it.